Okay, welcome back. So, last lecture we were talking about the plunging fold. Now, the importance here is that all is of the fold axis. Okay, if the fold axis is inclined, then we will call this as a plunging fold, and if the fold axis is horizontal, we will say non-plunging fold. Okay, and this is extremely important because we need to know that where to put tunnel, and if suppose you are planning to put tunnel here, then the tunnel will go through and through across this bed here. Okay, but if you are coming across the plunging fold, then your tunnel will last up to this only, where here you can go across this one. Okay, so that is very important in civil engineering, also for us in geology or the earth sciences. It is extremely important because we need to understand the evolution of the folds. So this is very important for us also. Okay, so the attitude of the fold axis or the hinge line is defined by two measurements, that is the bearing, the strike what we call, and its projection, the inclined or it is horizontal. Okay, so this we will talk about very quickly. So if the fold axis is inclined, then we term that as a plunging fold. So this has been represented like this, and can be plotted on a stereo net, that we will see in, very quickly in the next one. So here what we are adding is, we are adding more attitude. Earlier we just had in strike of the axial plane or the fold axis, but now we are having also the inclination. So this has been added here, and if you have this inclination with respect to the horizontal, then you term that as a plunging fold. So here is an example of the plunging fold, where you can see that there is a fold here. So from the front you can make out that there is a fold, but if you go further dip in this direction, then you see that it is dying out. Okay, so this is an example on this section. If you look at the plunging folds, will die out at a distance if you travel. Okay, they will not extend further. Okay, so accordingly you can, so but on this face or the section, you see a very beautiful folds which have been developed, so you may get confused. Okay, but one can sort out very easily if you are having the dip and strike of the beds or the limbs you are having. That can help you in identifying the whether there is a plunging fold or not. Okay, this is another important part where we talk about the difference in the strength of the layers or the strata or the beds, where we have like incompetent beds, two incompetent beds, and in between squeezed is your incompetent bed. Then during the folding, this incompetent bed will slip. Okay, and that is extremely dangerous, because you may say that the competent beds, no folding will take place and no slippage will occur, but the incompetent beds or the layers will have problems. Okay, they will slip and they will result into the displacement of the layers. Okay, so this type of folds are formed when competent bed slides over the incompetent one. Okay, so they are minor folds confined to the limbs of the major folds. Okay, so you will not be able to see this type of folds on a very large scale, but they are within the folded layers. Okay, so you are having, and they will slip like this. Okay, so you will have that what we call the drag folds. Okay, so these are the drag folds. Then chevron folds. Okay, they are again multi-layered. You will see in the multi-layered rocks. Okay, complexes, regular alteration of competent and incompetent layers again of the thickness T1 and T2 respectively, if you take the thickness of these beds here. Okay, and then with the high ductility, okay, in the compressional regime, they will result into the formation of chevron folds, and they will have the tip that is will be very sharp. Okay, so these are the hinge, what we call the hinge. Okay, the upper crust or the hinge lines or the hinges are very sharp and angular in shape, or it goes up to the angle of around 60 degrees. Okay, so this is an example of the chevron folds. You can see this hinge lines are very much sharp here. Okay, all these are very sharp. There is another example, and here you can see this is slightly bent in the axial plane. Okay, and then there is some slide of displacement over here, what we call as an fault. Okay, so this is an example of chevron fold, and the previous one was drag folding. Okay, now on the topographic maps also you can easily make out that how the landforms, like the folded areas, can be looked at. Okay. So if you look carefully the contour values and all that, and then spacing also between the different contours, one can make out that whether this is so this here they are very closely spaced, whereas here they are slightly widely spaced. Okay. So these are the escarpment or the limb of the fold, and this is either the top or the basin part. Okay. But you can, if you can see here, this is around 7,000 feet or either meter, and then there you are having, this is 6,800, this goes to 6,000. So the height is higher here, and then it reduces further down. Okay. So this could be like the step limb of one of the fold. Okay. And then again you are having 5,900 here, then you are having 6,000, and then you are having 7,000. Okay. So what we see here, if you look at the cross section here, then you have 7,000, then you are having the lesser one, then you are having again lesser one, then again slowly you are increasing. Okay. So this is what you are having the syncline here. So these 2 points are 7,000 here, what we see in the cross section, and then somewhere here is your 5,900, and then again you are getting up into 6,000. Okay. 6,000 you got here also. Okay. So this is what we can say, that this is an syncline, but this part is quite steep here. Okay. So this side is an anticline, and then other side, this one is your synclinal valley. Okay. Again, these are the few very important structures which are related to the anticline and syncline. So if you are having anticline structures here, and if they are eroded on the surface, then what you see is that the drainages are flowing away from the center. Okay. Whereas here, if you are having the basin or the syncline, then the drainage is moving towards the center. Okay. And the dip, if you see, has been shown here. Okay, with the smaller ones. So dip are like this is the strike, and this is the dip direction, this is the strike, and this is the dip direction. So they are dipping towards each other. So you are having the syncline here, whereas here similarly you are having the anticline which are dipping outside. Okay. So these are termed as these landforms which are associated with this, where you are having the older strata at the center. Okay. Older strata is at the center when the younger stratas are surrounding the older one, whereas here what you see is that you are having the younger stratas in and the older stratas out. Okay. So this is what is the difference between these two. Okay. So these have been termed as basin. Okay, and these are termed as the domes. Okay. Further, if this is another term which has been given as inlier and outlier. So if the older formations or the rocks are surrounded by the younger rocks, then they are termed as inliers. Okay. So older rocks surrounded by younger rocks. So this is your domal part which you are having the inliers. Okay. Whereas this one, if the younger rocks, we are having younger rocks are surrounded by the older rocks. So older rocks are on the outside here, periphery, then what we say this as an old outliers. Okay. So we are having inliers and outlier which are associated with the anticline and syncline, or we can say with the domes and basins. Okay. So these are inliers and these are outliers. Okay. So this also again you can you should remember about that. Okay. And one can identify this based on the drainage also. Okay. So this is another feature which is mostly associated with the larger folds, what we call the mega folds. Okay. So these folds are generally a part of the large fold, that is we term that as an anticlinarium or synclinarium, and they are been seen associated along within the limb of the major folds. Okay. So they are the smaller folds where again these have been termed as anticline and synclines that we are having, but they are termed as anticlinarium and synclinarium. Okay. And they extend for several kilometers. Okay. Along the major large folds. Okay. So folds are generally part of the large fold system. Example, this is a mega fold system Himalaya, and major large system anticline comprises many smaller size fold called anticlinarium, and the large synclines and the smaller folds associated with that, they are termed as synclinarium. Okay. This is an example of that how they this folded sections are been represented on the geological maps. Okay. So, these are the folded bits which are been shown here. So, if you add here with the depth direction and the strike direction, you can easily make out, or you can draw the sections also in this. Okay. So, plunging fold, again coming back. So, we are talking about that how we can plot this and know that whether it is in plunging or not. So, we will just move ahead with that. So, this is what we use as the stereographic projection. It is nothing but it is an globe like stereographic projection which has been given, and which is again representing the your coordinates, okay, or coordinate system, that is the latitude and longitude, and that is how they have been given. So, this is what we call is the wolf net we are having. Okay. So, this is the wolf net which is again equal areas. Now, you are having different lines along on the circle. Okay. So, you are having one is the what we call the darker lines here, and then we are having the lighter ones here. Okay. So, we are having those lines here, and then we are having few lines which are been in cross cutting, like it is running east to west, where they are running north to south. Okay. So, north to south are our longitude, they are representing the great circles, they are representing your longitudes, and then smaller circles here or here they are representing the latitudes here. Okay, fine, and the center is the east west is your equator. So, this is the representation of that. So, what we see here, the plotting of the attitudes of the rocks. Okay. So, we have the strike and we have the depth. So, we can plot that on the stereo net and try to understand that what type of fold those limbs are associated with. Okay. So, stereographic net is a projection of latitudinal and longitudinal lines on a sphere. Okay. This net is known as wolf net. Okay. Wolf net stereograph, which exhibits divided area of equal angle. Okay. So, this all are representing angle. Okay. So, this is 0, this is 90 degrees here, and this is your 180, this is your 270 back to 0 here, or you can say it is 360. Okay. So, this is what you are having, the representation of the equal angle, and this all are like equal angle. So, we are having this as an this is 90 here, and you can say 80, then 70 and so on. Okay. Now, why this is important and how we can make out whether the fold is plunging or not. Okay, let us see. So, the lighter lines what we are having inside is equal to 2 degrees, whereas the darkers are representing 10 degree. Okay. So, this all are 10 degrees here, this one is 10 degree, whereas the inner one, the lighter lines are all your 2 degrees. Okay. So, we have like for example, we will collect the information from the field, and then we can plot it on the stereo nets. Okay. So, stereographic projections displays geometries and orientation of the lines and planes. Okay. So, that is the strike and dip of the planes, and it is used for solving apparent dip. So, if you are having apparent dip, so you can easily make out and try to identify the true dip also of that area. Okay. Then trends and plunge of the intersecting planes, with the help of that you can make out that whether it is in plunging fold or non-plunging fold. Sorry. So, what we will look at. Okay. So, suppose we are having an inclined plane here, and that need to be projected on the stereographic projection. Then what you will do is that you will project on, this is what we call the plane or the center of the hemisphere. So, we are having a plane area, and this has been projected on the flat or the flat surface. That is what we call the stereographic projection. Okay. So, the imagine that the plane passing through this one, or this plane what we see here is passing through the center of this and the hemisphere. Then how they will be, it will be projected on the flat circular plot. Okay. So, this will be representing your this is your the plane on the circle here. Okay, so this plane is like, this is your strike here, and this is your depth what you are having of the plane. Okay, so with respect to, so this is an angle here, so that what you have projected on the flat circular plot. Okay, now taking this very quickly we will look at, and you can do one of the exercise will be given to you. Now we are having the attitude of the one plane. Okay, so for example we are having here, so what we have is the this is your strike, that is 40 degree, and then we are having the dip direction, and then we are having amount of dip is 45 degrees, and then we are having the dip direction is 130 with respect to north. Okay, so and we are having this 140 degrees. So what we need to plot is that we need to plot that with respect to north, this is your 40 degrees which is coming here. Okay, so with respect to north we are moving, so this will be your strike here. Okay, which is passing to the center of the flat plot or the projection. Okay, and then amount of dip you are having, again it is dipping in like towards 130, so this will be your 130. Okay, and then you are having that dip as amount as around 40 degrees, so that is been measured from the outer circle towards the center here. Okay, so let us see how we can project this on this one. Okay, on the stereo projection. So pole, this is what has been, and then if you take this from this point 90 degrees, so you can take this 90 degrees, that will be your pole which you represent on the intersecting part. Okay, so that is the that will give you all information about the planes and all that. Okay, so to know the concentration of the strike and various beds, so if you just plot the pole, that will also help you in knowing the strike and depth of the beds. Okay, so if in most of the stereographic projection, what has been done is that you have the poles which are plotted, and the concentration of the pole will tell you whether what are the maximum strike, okay, or the concentration of the strike of the beds or the direction of the beds, and what is the inclination of the beds here. So coming to this, if you see carefully this one, this will explain you that how it has been projected. This is how the pole has been projected. So you are having the inclined plane here, and that is from that point you are taking 90 degrees, and then you are putting that pole here. Okay, so that is the point, that is the pole is representing the point, and complete data of strike and depth here. Okay, so the next part we will see that how, if you are having two beds, how you are plotting those. Okay, so for example we are having the fold, and we have two beds which are having attitudes, that is having the strike and the depth. Okay, so one is like we have this, that is 34 degrees, and then we have, so this is your strike, this is your amount of depth, and this is your depth direction. Okay, and similarly the another one we are having is around this one. Okay, so let us see how we can plot this one. Okay, very clearly. So attitude of beds, one limb is oriented in this one, that is 325 degrees, 70 degrees northeast, and another one we can also say this one is north 20 degrees, okay, and 40 degrees you are having northwest. Okay, so this is again another plane we are having. So if we so in this case the strike of the fold axis will be at 334. Okay, so this is the, sorry, this one what is been given is the strike of the fold. So this is the strike of the fold. Okay, so we are having two beds here, one is the blue line and this is your red line here. Okay, so let us see how we can plot this one. Okay, so let me remove this one quickly, and then we can see. Okay, so we have one, that is what we have marked is north 20 degrees. Okay, or you can, sorry, this one we can take first, that is the 325. Okay, so this we have taken, this is 325 degrees. Okay, we have taken the mark, and then what we will do is we will try to measure the depth. Okay. And since this is our east quadrant, so we will move this mark parallel to this one, okay, that is to north. Okay. So what we have done, and when we will measure this one, so we have moved this parallel to the north, and then we have marked the outer line, that is this one. This is 70 degree northeast. So this we have marked from here. So we will start from this is in the northeast. So north, from the east we will go in this direction. So that will give you, that plane will give you the plane of your fold. Okay. And if you mark this, so this will be your strike. Okay. This will be your strike here. So then you move back, and this will be left out with you. Okay. So this will go off. Okay. So this we are having the one plane you got. Okay. That is with 70 degrees. Okay. And then another one you are marking, that is 20 degrees. So north 20 degree. So you have 10 and 20 here. Again you are having this amount of dip is 40 degrees, which is a northwest. Okay. So you have to go in this quadrant. So this is your west, and again you have taken 10, 20, 30 and 40 here. Okay. So you have taken this, again you will move this towards north and then bring it parallel to this one here. Okay. This one here, and that will give you the plane here. Okay. So you are getting this plane. So again you are getting another one, that is the blue plane you are getting, and you will get this the information here. Okay. So again you move back in the same fashion, bring your north, which was been initially marked. So you, when you start this, it is better to mark the north, south and east, west. Okay. So that will help you in bringing back the your tracing, and this has been done on the tracing sheet. So you will put the stereo net, and you can do this on the tracing sheet. So you can bring it back, and then what you have is that you see that the two limbs, okay, which you have drawn are not intersecting along the outer circle. Okay. They are intersecting within that. So this means that it has some sort of an attitude. Okay. So this is in fold axis, because when we were talking about the intersection, this what we have drawn is the intersection of the two planes. Okay. So this is your fold axis. Now either the fold axis is vertical or the fold axis is inclined. Okay. Or it is plunging or not plunging. Okay. That we can make out easily. So what you got is that if you again bring this at the center here, and then again you measure. Okay. So this will be your the direction, this is your fold axis here. So you got, and then amount of dip you can measure from here when you bring it on the center. Okay. That will give you the amount of dip. So when you bring this whole part here, because you have the center here, and then you can measure from the center here that how much is the amount. So that gave this 30 degree, and since you are again putting back, so this is in the western side. So you will say this is dipping towards northwest. Okay. So that is what you have done here. Okay. So you were able to measure with the help of two limbs. Okay. And the intersection not along the outer circle. Then you have named you have calculated the strike. You got the strike, you got the amount of dip, and then you got the direction of dip of the fold axis here. Okay. So this is your fold axis. So there are some symbols which you can go through, which indicates the strike and dip, and mostly you will find this type of symbols on the on your geological maps. Okay. So you are having horizontal, you are having incline, you are having syncline. Okay. You have overturned folds, you are having strike and dip of the foliations. This is related to the metamorphic rocks which we were talking about, the foliated and non-foliated rocks. Then you are having the strike and dip of the inclined joints, and they are having vertical joints, then you are having horizontal joints, then you are having anticline with overturned folds, then syncline with overturned folds. Okay. And then you are having the plunging anticlines. Okay. So if you are having these symbols which are been given, then you can easily make out that what is the plunge amount and what is the plunge axis, and in which direction it is plunging. Okay. So these are some of the symbols which are been given, which you can study from the slides. Okay. and I'll stop here, and I would like to start a new topic. Hopefully we have enough time to complete that also. So we'll talk about the faults. Okay, so we have been talking about the folds, and we talked about the different type of folds, but now the important part which is there, which we talk about the faults. Okay, so please remember the different type of folds which we have talked about the anticline, syncline, about the plunging fold, non-plunging folds, how to measure it using the stereographic projection, and then you can talk about or based on the slides and the notes, you learn about the symmetrical fold, asymmetrical folds, and then overturned folds, recumbent folds, chevron folds, and then you can learn about the drag folds and also the isoclinal folds also, or monoclinal folds. So these are the different type of folds. So based on everything is dependent on the fold axis, or you can say in which direction the limbs are dipping and at what angle. Okay, as we have talked about the open fold, closed fold, tight folds also, so you can learn all this. Okay, and I'll stop here. Thank you so much.